Okay, guys, so after doing the notes on independent versus dependent events, I want to give you a little demonstration. I'm going to use my daughter's toys here to help us out and give you an idea of how to find the probability of two events if they're independent events and if they're dependent events. So let's start. First of all, we've got a total here. Let's say I have all these marbles in a bag, okay? I have 3 green, 4 yellow, 2 blue, and 6 red. So the first thing I'm going to do is count the total. So altogether, I have 15 marbles, okay? So let's just keep that in mind. I've got 15 marbles in a bag, and these are the colors. Now, I wrote down a few probabilities to help us out. Let's start with independent events, okay? I want to know the probability of selecting a blue and then a red marble. The thing is, if they're independent events, that means that I am replacing the marble after my first selection. Sorry, that's just my daughter. So, the probability first of selecting a blue. Well, out of the 15, there are 2 blue, right? So, the probability of selecting a blue would be 2 out of 15. Now, let's imagine I select that blue after the first try, okay? When I go to select the red, I am replacing the blue back. So I still have all 15 when I go to select a red marble. So now, what's the probability of selecting a red? 6 out of 15. So, probability of selecting a red is 6 out of 15. And now, like it was explained in the video, we multiply those probabilities together. Now, these could turn out to be some big numbers, which is fine. You can always reduce at the end. But remember, it's always easier to reduce while you multiply here. So I'm looking at 2 and 15. I can't reduce. But 6 and 15 can both be divided by 3. So this becomes a 5. This becomes a 2. And then I multiply across. 2 times 2 is 4. And 5 times 15 is 75. So the probability of selecting a blue, replacing it, and then selecting a red is 4 out of 75. That's our probability. So those would be considered independent events. Now we're going to do 2 examples of dependent events. So the reason they're dependent is because I'm not going to replace the marble after the first selection. So the second pull here, the second draw, depends on what happens in the first. So let's take a look. What's the probability now of selecting a blue and then a red, but not replacing it? So again, from the beginning, I have all 15 marbles. What's the probability of selecting a blue? Well, it's still 2 out of 15. So I'm going to write that down. The probability of selecting a blue from the beginning is 2 out of 15. But now you have to imagine that that blue is taken and not replaced. So now what's the probability of selecting a red? 6 out of no longer 15, there are now 14. So there are now still 6 red, but there's only 14 total. Now I'm going to multiply just like I did before. And again, instead of just multiplying and reducing later, I'm going to reduce first. So 6 and 15 can both be divided by 3. This becomes a 2. This becomes a 5. And 2 and 14 can be divided by 2. 1 and 7. So now I multiply across. 1 times 2 is 2. 5 times 7 is 35. So 2 out of 35. The probability of selecting a blue and then a red without replacing is 2 out of 35. The last dependent event we're going to do is to figure out what's the probability of selecting a red marble, not replacing it, and then selecting a red again. So back to the beginning, I have all 15 marbles. So the probability of selecting a red is 6 out of 15. Okay, so I'm going to write that down. Probability of selecting the red first is 6 out of 15. Now again, with dependent events, you have to imagine that I did actually select a red on my first draw. So now, what's the probability of selecting a red again? Well, there's now only 5 red out of a total 14 marbles. So my new probability here is 5 out of 14. So again, the total changed because I didn't replace it, and the number of red changed because we have to imagine that I selected the red on the first draw. And again, I multiply my probabilities. Lots of reducing to do here. 5 and 15 can be reduced by 5, so that becomes a 1, becomes a 3. And 6 and 14 can both be reduced by 2, becomes a 3, and becomes a 7. So we multiply across. 3 times 1 is 3. 7 times 3 is 21. And then I can reduce again. Divide by 3. 1 out of 7. So I have a 1 out of 7 chance of selecting a red marble, not replacing it, and selecting a red again. So I hope these examples helped. Those noises in the background is my husband playing with my daughter, so I hope that wasn't a distraction. And I hope this helped make sense, guys.